Hello everyone, this is our first video lesson, and in this lesson we are going to review dimensional analysis. Dimensional analysis is often used to convert units, not metric prefixes, but like to go from US customary units to perhaps SI units or vice versa. Dimensional analysis is also a really good logical way to show your thought process or to show your work. And so there's kind of like a format that we're going to use. So you need to have the guided notes in front of you, and you also need to have this chart of common conversion factors. You don't need to memorize any of these. You can always use this chart, and you probably know some of them, but in case you don't. Notice that they're kind of grouped. If we're talking about lengths, just look in this area, masses and weights in this area, volumes, and then times are down here. So let's buzz through a couple of quick examples. All right, the first thing we're going to do is we are going to convert 5 slugs into pounds. So to do that, we end up using kind of a format that looks like a fraction. So I'm going to do parentheses and I'm going to put a fraction bar in there. And we are going to convert 5 slugs. So I'm going to write that down in the numerator, 5 slugs. And the denominator is going to be blank. But when we get down to, for example, number 4, when it says 60 miles an hour, 60 miles goes on the top in the numerator, and then underneath is the hours. But we only have 5 slugs, so there's nothing underneath. That's okay. All right, so then I'm going to set up another one with a fraction. And I also like to kind of write myself a little note over here so I kind of remember what I'm doing. So I'm going slugs to pounds. So I'm going to write down slugs to pounds. That's why I call this a 1-unit conversion, because I have one thing that I need to convert, slugs into pounds. All right, so in this fraction here, we have to write down things that are equivalent. So I'm going to look at my chart, and I'm going to look in the mass weight column, and I'm going to try to find something that connects slugs in pounds. How about this one? 1 slug is 32.2 pounds. So since slug is in the numerator here, I need it to be in the denominator here. So I'm going to say 1 slug is 32.2 pounds. All right, and the reason I did that is because if you were in math class, and if you have a slug on top, you can cancel it with the slug on the bottom. And then look what you have left. Pounds. That's what we're looking for. That means we're done. So this one was really easy. So now I'm going to make a fraction bar. And what you do is you multiply everything across the top. So I'm going to take 5 times 32.2. Let's pull out the calculator. And let's go 5 times 32.2. And I get 161. I'm going to write that down, 161. And then you multiply everything in the denominator. I only have a 1. 161 over 1 is 161 pounds. So that means that if you had a mass of 5 slugs, that's equal to 161 pounds. All right, let's try another one that's a little bit longer. So in this example, we have a car that weighs 4,000 pounds. So I'm going to start my little fraction thing again. And I'm going to put 4,000 pounds up here in the numerator. And there's nothing in the denominator. I'm going to write myself a little note. I have to convert this to newtons. So I have to go to pounds to newtons. All right, so I gotta fill this in with something that's equivalent. Pounds to newtons. When I look in this chart, none of these are pounds to newtons. So that means I can't do it directly. I'm just going to have to pick something that might help me out. How about this one? 1 kilogram is 2.2 pounds. 1 kilogram is 2.2 pounds. So 1 kilogram is 2.2 pounds. How do you know if you put the kilogram on the top or the bottom? How do you know? You look at this. If you have pounds on top here, you need pounds on bottom here. So they cancel. Now I'm at kilograms. How could I get to newtons? Kilograms to newtons. How about this one? 1 kilogram is 9.8 newtons. That's a fact. That's an equivalent fact. So I'm going to put that here. I have a kilogram on top, so I need to make sure the kilogram ends up on the bottom. So 1 kilogram is 9.8 newtons. Kilograms cancel. And that's what I want, newtons. I'm there. That means I'm done. So I'll make the fraction bar. And I'm going to multiply everything on top. So I'm going across. That's 4,000 times 1 times 9.8. So 4,000 times 1, you don't really have to do the 1, times 9.8. 39,200. 39,200. And then I have to multiply everything in the denominator. That's going to be 2.2 times 1. That's 2.2. Now I'm going to divide that. 3,900 divided by 3,200 by 2.2. And I get this answer. And I'm just going to round everything off to one decimal place. So that's going to be 17 point, I'm just rounding it off to a 2. And that's newtons. So 4,000 pounds is 17,000 some newtons. You can see that. All right, the next one's even a little bit longer. So save yourself some space. All right, a student runs a 5K race. How many feet did she run? So you have to know that a 5K race, that 5K is 5 kilometers. So I'm going to go over here. And I'm going to make this 5 kilometers. And I'm going to make myself a note that I'm going kilometers to feet. And these are lengths. So I'm going to look over here in the length category. You'll notice there's nothing that goes kilometers to feet. That just tells you that it's going to take you multiple steps. And I'll also tell you that there's multiple ways to get this answer. I might choose a path that's different than the path that you might have chosen, or your friend, and that's okay. All right, so I have 5 kilometers, and I'm trying to find something that might help me get to feet. So I'm going to pick this one. And sometimes you pick one, and it's a dead end. Then you just got to try it over. But I'm going to pick this one. 1 kilometer is 1,000 meters. So let's write that fact down. So 1 kilometer is 1,000 meters. And I knew the kilometer had to go in the denominator because I wanted to cancel them. All right, now I'm at meters. Can I go meters to feet? There's nothing on here that's directly meters to feet. So I'm just going to have to kind of pick something. Meters to something. Meters to something. How about meters to centimeters? Let's try that. Meters to centimeters. So 1 meter is 100 centimeters. Then the meters cancel. So now I got centimeters. Centimeters. And I got to get to feet. What if we took centimeters to inches? That might help. So let's try that. So, centimeters to inches. 1 inch is 2.54 centimeters. Now the centimeters cancel, and I have inches. I could go from inches to feet because I know that 12 inches is 1 foot. And then inches cancel. And there's my answer. That's when I know that I'm done. So let's figure out what that's equal to. So I'm going to set up my little fraction. And I'm going to multiply all of the stuff in the numerator. So 5 times 1,000 times 100 times 1 times 1. So that is going to be 5 times 1,000 times 100. 500,000. 500,000. So 500,000. And then in the denominator, I have 1 times 2.54 times 12. So 2.54 times 12. 30.48. 30.48. Now I'm going to divide those. So 500,000 divided by 30.48. 16,404.2. 16,404.2. 16,404.2 feet. So if I run a 5K race, you ran this many feet. Dimensional analysis is a real simple way of showing your work when you convert units. So now let's look at a couple little bit more challenging ones, because these involve 2-unit conversions. So because they're 2-unit conversions, they're going to even be probably longer than these. So that just tells me that I should probably start to write small. Okay, so we are trying to convert now 60 miles an hour to meters per second. So I'm going to start with my fraction, and again I'm going to try to write a little smaller. 60 miles per hour. So 60 miles. This bar is the per hour. So you can only have 1 unit in a box. You can't write 60 miles per hour on the top. You have to write 60 miles on the top. Hour has to go in the bottom. All right, so, and then I have to convert that to meters per second. So I'm doing miles per hour, and I have to convert that into meters per second. So you can see that I'm going to have to convert miles to meters and hours to seconds. That's why it's called a 2-unit conversion. So I have to do like 2 problems in one. All right, so let's just start with trying to get miles to meters. Let's just start there. Miles to meters. What do I know about miles to meters? There's no miles to meters. So how about this? 1 mile is 1.6 kilometers. Let's start with that. So 1 mile is 1.6 kilometers. Because then the miles will cancel. And now I have kilometers. Could we get from kilometers to meters? What about this one? 1 kilometer is 1,000 meters. Let's try that one. So 1 kilometer is 1,000 meters. Again, I knew kilometer had to go on the bottom because this one's on the top and I want to cancel them. And there it is. I got my meter. So I did this part of the problem, but I still have another part of the problem to do. I have to turn this hour into seconds. So I'm going to continue the problem. I'm just going to switch colors so that you can see that I'm on the second part of the problem. And no matter what I do, I know that the hour has to be on top so that I can cancel them. So I'm going to put hour. What do I know that could help me get to seconds? Well, you can look at the times, but I think you already know all of these. How about this? 1 hour is 60 minutes. Then I can cancel this hour and this one. So now I've changed hours into minutes, and I got to get to seconds. So how about this? 1 minute is 60 seconds. Cancel, cancel. And I'll circle that. So I now have a meter on top, and I have a second on the bottom. That's exactly what I want. Now I just got to figure out what it's equal to. So again, I'm going to multiply everything on the top. So 60 times 1.6 times 1,000 times 1 times 1. Let's do that. So we have 60 times 1.6 times 1,000 times 1 times 1 is 96,000. 96,000. 96, 1, 2, 3. All right, on the bottom, I have 1 times 1 times 60 times 60. So I'll skip the 1 times 1s. 60 times 60, 3,600. 3,600. Now I'm going to divide them. So 96,000 divided by 3,600. 26.7 if I round it off. 26.7. 26.7 meters per second. So we have speed limit signs that say 60 miles an hour. We could replace them with speed limit signs that say 26.7 meters per second, and the cars would be driving at the same speed. All right, one more to do for our notes, and then there's some for you to practice on the homework assignment. All right, in this case, this sounds more like a physics problem, and this might have been something like that might have shown up like on one of your quest assignments, but I want you to see now how you could have used dimensional analysis to try to answer a question like that. So it says a faucet drips at a rate of 5 milliliters per minute. How much water in gallons per day will be lost? All right, so again, this one's kind of long, so I'm going to write small. And we have a faucet that's dripping 5 milliliters per minute. So 5 milliliters per minute. So you can't put the minute on the top, only one unit in the denominator, or numerator, only one in the denominator. All right, I'm going to make myself a little note over here. I'm going milliliters per minute and I have to turn those into gallons per day. So I got to do milliliters to gallons first, and then minutes per day. Minutes to day second. So that's why it's called a 2-unit. Could you do them in the opposite order? Yeah, you can. I always just do the numerator first. All right, so I'm working on that milliliter, and I'm trying to go to gallons. So milliliters and gallons, that's over here in the volume stuff. So what could I pick from milliliters that could help me get to gallons? How about, let's start with this one. How about this? 1 liter is 1,000 milliliters. So milliliters is on top, so I know milliliters has to be on the bottom. So I'm going to put the 1,000 here. 1 liter is 1,000 milliliters. Cancel, cancel. All right, so now I got liters, and I need to get to gallons. Can we go from gallons to liters? How about the first one right here? 1 gallon is 3.8 liters. Liters is on top, so I need it on the bottom. So 3.8 liters is 1 gallon. Cancel, cancel the liters. And there's my gallon on top that I need. So that tells me I'm halfway done with the problem. So let's now, let's do the second half. So now I have to get this minute into days. I'll do this one a little bit faster because you know these. Minutes to days. How about that there are 60 minutes in 1 hour? Since the minute was down here, I put it up here. Cancel, cancel. Now I'm up to hours. How could I go from hours to days? There are 24 hours in a day. The hours now cancel, and there's my day on the bottom. So that tells me that I have everything. Let's just figure out what it equals. I'm going to multiply all the numbers on the top. So 5 times 1 times 1 times 60 times 24. So let's say that again. 5 times 1 times 1, I'm skipping those, times 60 times 24. 7,200. So write that on the top, 7,200. And on the bottom, we have 1,000 times 3.8 times 1, and there's a 1. So 1,000 times 3.8. 1,000 times 3.8. 3,800, we knew that. We didn't need the calculator for that. 3,800. Now I'm going to divide them. 7,200 divided by 3,800. And I'm going to round off to 1 decimal place. So that would be 1.9. I don't know why that's so blurry on my calculator screen, but it's 1.9. All right, 1.9 gallons on top, day on the bottom. Gallons per day. So if your faucet was dripping 5 milliliters every minute, you would end up with 1.9 gallons by the end of the day. And so dimensional analysis is a way that you can convert units, but it's also a way of solving like physics problems by using the process of dimensional analysis, and you've shown your work in a very nice and logical way. So there are some practice problems on the homework assignment, and you can use the set of guided notes just to help you get started. So thank you for listening, and this is the end of our first video lesson.